Perfect. One. Someone joined. A very good afternoon. We'll start in the next 2 minutes. It's about 2:58. We'll start around 3. Gopal sir, can you mute yourself? There is a lot of background noise. A very good afternoon. We'll start in next 1 minute. Guys, if you don't have any doubt, please mute yourself. Okay, I'll do. I should present also entire screen. Stop. Okay. Okay, guys, we can start now. So, the week 4 on this introduction to material science and engineering course has been over, and in that course we discussed a lot of things about the symmetry, mostly about the crystal structures, rock salt. We saw cesium chloride structure, we saw zinc ZNS structure, so on and so forth, and we also discussed about the polymers like thermoplastic, thermoset polymer. We discussed about the tacticity, the crystallinity in the polymer. Those things we have discussed. So let's just go through the list of the content that was covered in this particular week. Just a reminder that what and all we have covered, so that if you face any doubt in them, you can let me know and we can have a detailed discussion on that. So our discussion was entirely on the carbon nanotube. Then we went to the buckyball, where we saw that okay, buckyball will be having the FCC crystal lattice. Okay, it will have FCC lattice. While at each lattice point there is 60 carbon atoms are sitting. So the motive is consisting of the 60 carbon atoms. So one buckyball is sitting at the one of the lattice point. Then we discussed about the NaCl, cesium chloride, and zinc sulfide ionic solids. We discussed that why cesium chloride cannot be considered under the BCC. Then we shifted toward the amorphous solid. We discussed about the polymer. We discussed about the thermoplastic, thermoset, tacticity, copolymer, and crystallinity in the polymer. So these are the lists of the content that has been covered in the week 4. So if you have any doubt in this particular content, please let me know. We can discuss them. If there is not, we'll move toward the question side. The question which I designed today is majorly on the based of the what we can say the assignment question I was telling about. So you will find resemblance in them, that more or less they will be similar with each other. Okay, since there is no doubt, let's move to the questions, and I would request all of you to please write your answer in the comment box. You can also unmute yourself and discuss with me. So here is the first question. It's a very easy question. So Abhishek, Banu, and Swapna, Rami Reddy, yeah. Oh, you joined again, yeah. So last time also we met all of you. It was great. So, so yeah. So what is the best way to describe the carbon nanotube? We are talking about the CNT. Okay, so Reddy has told that its option B is the right answer. CNT, we know that we take a graphene sheet and then we rolled it. Okay, so a rolled up graphene sheet. It's not the single layer, no. A form of the amorphous carbon, no. The mixture of the graphene and the graphite, option B is the right answer. That's what you have told. It's perfect. So all the questions most of the questions, majority of the questions today will be like this. It will be rapid fire type question, you can say. So now let's go with the one of the match the following, where we have to match 1, 2, 3, 4. We have to match carbon nanotube. Carbon nanotube will match with each other. Okay. Yeah. So that, yeah, right up. That's what we discussed. That it will be the rolled up graphene sheet. So it's the option C. So what about the second one? Second is match with the D. Yeah, Reddy has told that it is the like discovered in the 1991. Perfect. So it will match with D. Russian doll structure. So Russian doll structure, we know that it is like a option A, right? Concentric. So one graphene sheet will be there, then another rolled up, then another rolled up. It will be like that. So it will match with the option A. So 3 is going to match with it. 4 is an armchair nanotube. An armchair nanotube resemble like an armchair at tube edge. That's right. Option B. Right? Yeah, that's great. So C, D, A, and B we have got. With that, we have solved this question. Let's move to the next question. By the way, if you feel any doubt now, please feel free to interrupt me and we'll discuss that. So this is telling that what is the crystal structure of the solid C60? Buckyball, BCC, FCC, HCP, or simple cubic? So which lattice it is going to fit in? So we have the buckyball, and we want to know that which of the crystal structure they will form. So we know that in the buckyball, FCC, right? The perfect. It will form the FCC. So see, it's very interesting that in FCC we are having the multiple lattice site. Whatever I have drawn here, it's the lattice site, not the atoms and all. Okay. So now at each lattice site, one buckyball is coming. C60 is coming. So there will be a lot of atoms sitting at the one lattice site. So here we can see that how many motifs are there. So crystal structure, we can say that overall we can say that lattice is FCC, while the motif is consisting of the total, we can say that the 60 carbon atom. Right. And that's how we have solved this question. That option B is the right answer over here. Let's move to the next question. So it's a true or false. So we'll go one by one. Gitu, can you please tell them? They are making a lot of noise. I have to record this video. True and false. So C60 contains only hexagon in its structure. So it's a false, right? Perfect. The structure of the C60 is based on the truncated icosahedron. What do you think? Again, it's a false, right? No, it's a true. Perfect. It's true. That's how we solved A and B. Now, each carbon atom in C60 is bonded to the 3 other carbon atoms. What do you think? Is it true or false? Each carbon atom in C60 is bonded with the other 3 carbon atoms. It is true, right? Yeah, perfect. So, the face-centered cubic FCC structure of the C60 mean that individual carbon atoms sit on the lattice point. So, what is your comment on this? They are telling that, okay, that C60 is having the FCC. It's a false, right? Yeah. So Sunabha and Mani Reddy, both of you are perfect. Right, it's right. So we can say it's a false, right? The group of atom will sit at the lattice point. Yeah, that's perfect. And that group will be consisting of the, like it's an entire molecule, it's an entire one buckyball is there, which is sitting at that particular point. So we can say it's a false. Yeah, and the final one, we are having a pure crystal of C60 consists of the molecular arrangement in the FCC lattice. It's a true, right? Perfect. That's how we can do it. So with that we have solved the question number one. Right. Let's move to the next question. Question number 5. Which type of bonding do metal exhibit? It's a very easy. I want all of you to answer. Abhishek has told that it's a C. Reddy has also told that it's a C. So right. Yeah. Okay. Yeah. All three of you had told that it's a C. So it's a metallic bond. Ionic and covalent we saw in the. We'll see. We can see the covalent bond in larger extent in the polymer, and the ionic and covalent we'll see in both of the. We can say in the ionic and as well as sorry in the ceramics material. So ionic bond and covalent bond we can see in the ceramic material, while the metallic bond will be exhibited in the. And van der Waal again it will be there in the polymer. Now, what is the critical radius ratio for the stable triangular coordination of the cation and anion? So, what they are telling that cation and anion they are talking, it means that we are talking about the ceramic. We want to minimize the repulsion between the cations and anions. We don't want anions to come together. Okay. So we don't want that. Okay, like something like this to happen. While the cation is very small, they will repel each other, right? We want little bit of stable. So we want stable microstructure, stable structure. So it should be like something like a cation will be there 0.155. That's right, perfect. 0.155 is the right answer. So this structure is stable. This is not stable. It's a critically stable, just a point where these anions are separated out. So with that we can say that okay, this is the one which will follow. So if the radius ratio is larger than this, then our structure is stable. If it is smaller than this, then it is not stable. Then it will not form the triangular. Whether it will go, so it will go to the linear 2 dimension. So the cation will be over here, and anion will be over here. They not listen to you. They not back answer you. Okay. So this is how it is. So we got to what we can say, two cations which are separated by the anions in between them. And that's how we have solved this question, that okay, for the triangular coordination radius ratio should be greater than 0.155. If there is any doubt, let me know. If not, let's move to the next question. What is a coordination structure? Which coordination structure have a critical radius ratio of the 0.225? A tetrahedral, right? Perfect. So we have saw that for the tetrahedral, this structure, if we place the cation or other atom over here, other ion over here, then it should be the radius ratio should be greater than RC by RA. It should be greater than or equal to 0.225 for it to be the stable. For the critical radius ratio they are asking, so we'll consider this equality sign. So with that, tetrahedral is the right answer. Oh, that's great. All of you wrote the right answer. Okay, let's move to the next question. Okay, we'll do it one by one. Okay. Dash bonding is non-directional, allowing for the close packing. What do you think? What should we write in this fill in the blanks? Dash bonding is non-directional. Is ionic, covalent, or metallic? What should be? Which bond? Metallic, right? Yeah, that's perfect. Ramiredi has told that it's metallic. We know it is non-directional. and which is leading to the close packing in the metals. Now, let's move to the next question. Cation size is usually dash than the anion size in the ionic solid. It's we can say that more or less smaller than or the larger than smaller, right? Yeah, perfect. So Abhishek has told that smaller. In a stable ionic structure, cation prefer to be surrounded by dash to maximize the electrostatic attraction. It's very easy. Cation will surround itself with what? With the opposite charge anion, right? Perfectly ready. Yeah, that's great. Anion. Okay, we have two more. The critical radius ratio for the octahedral coordination is, what do you think? For the octahedral coordination, that is, we have to be more than 6. Sorry, octahedral coordination, no? So it will be 6. Coordination number will be 6. 0.414, that's right. Now the final one. Which type of coordination have the cation is surrounded by 8 anions is called, the type of coordination where cation is surrounded by 8 anions is the called that's coordination. Cubic. That's right, perfect. Good. So Reddy has told that it's a cubic. So with that, we have solved all these questions. Let's move to the next one. Question number 9. Question number 9 is very easy. Okay. So the what we can say that particular coordination is given over here and the correspondingly radius ratio. So 1, 2, 3 and 4. Let's match them. 1 is going to match with the, okay, radius told that it will be the B, perfect. Tetrahedral will match with the C, perfect, yeah, it will match with C. And octahedral will match with what do you think? We just now answered this thing, yeah, it will be the D. And the cubic is going to match with 0.7. That's right, perfect. So A. So that's how we have solved this question. Question number 9 is over. So in the NaCl crystal structure, how many chlorine ions surround a single sodium ion? What is your opinion on this? 6. Okay. Okay, yeah. So yeah, that's right, perfect. And why is it that we know that sodium is sitting at the octahedral position? Octahedral means the 6 coordination number. That's how we can say it. Here we can, in NaCl we can say that, let me check the other questions. Am I including the thing which I am going to say? No. So in NaCl we know that it is a FCC. One can consider that it is a FCC made up of the chlorine atom, chloride ion. So in corresponding to this FCC we have octahedral void. And in that octahedral void we can say that sodium is sitting. And we know octahedral void have the total of 6 coordination numbers. That's right. Let's move to the next question. The motif of the NaCl structure consists of which of the following? So we know the lattice we just talked about, it's a FCC. What about the motif? Will it be only sodium? Will it be only chlorine? Or will it be sodium, one sodium or one chlorine will be there? Or 2 sodium or 2 chlorine will be there? What do you think? This thing has been discussed in the class. That's a C answer is the right answer. So Reddy has told that it's a C. So it will be consisting of the sodium ion and chlorine ion. So if chlorine is forming the FCC, so we can say chlorine will occupy 0, 0, 0, O, and sodium can take the 1 by 2, 1 by 2 and 1 by 2. This is one of the motif. And also we have studied that sodium can take one more side, like chlorine is taking O, while sodium can take O half shifted by the half. So one can consider any one of them. Okay, either they can consider it or they can consider this, and both of them are right. That's how we have solved this question. Let's move to the next one. If there is any doubt, now guys, please feel free to ask me. Now, based on the radius ratio of the CSCL, which type of coordination is expected? Okay. What do you think? It's a cubic X expected, right? Because we know it's 0.7414 greater than, if the coordinate number is more than this and less than 1, then it will be cubic. If it is equal to 1, it's a cube. Am I making any mistake over here? It's a cubic, huh? No, it's fine. Yeah, perfect. Okay, so that's how we have solved this question. Let's move to the next one. No, wait a minute. If it is greater than 0.11155, if it is more than that, it will form the coordinate number of 3. 0.225 will form the coordinate number of the 4. 0.414 will form 6. If it is greater than 0.732, it will form 8. And 8 is correspond to the cubic. Yeah, perfect. Yeah, sorry, I was little confused. And that's how we have solved this question. Yeah, let's move to the next one. Why is CLCL structure considered simple cubic rather than the body centered? So people are saying, like they are asking that CSCL, there is at the body center there is an atom, there is an atom at the lattice points also, like those we can say at the corners of the cube. Then why not we call it the BCC? Why you are calling it to be the different structure, CSCL structure? So what do you think? Which one is the right answer? A, B, C, or D? A. Okay. A. The atom in the body center and the corner are chemically different. They are not equivalent. They have to be equivalent with each other. Then only we will consider them to be the BCC. If they are not, they will be considered separately, and that's how we can say that option A is the right answer. Let's move to the next question. What is the prototype structure of the CSCL? You can answer. What do you think? Among this A, B, and C, A, B, C, or D, which one is the right answer? It's very easy. We just discuss it. Yeah, that's ready. That's right. Ready. So D is the right answer, where we can say that one of them will form the cube and another will be sit at that particular void, forming at the center of the cube. So let us say this is the chlorine. This we can say that this is the CS. So at the center, AB type. Now why we are calling it the AB type? Because see, the contribution of A is 1 and contribution of B effectively it will be it will come to be the 1 overall. Okay, we'll take this 1 by 8, 1 by 8, 1 by 8, we'll add them up, it will be 1. So it is a AB type structure. And for the CSCL we say that okay, this is what it is happening, that anion is sitting at the center or other way around and cation is sitting at the corner, vice versa. And that's how we are done with the question number 40. Let's move to the next question. Based on the radius ratio of the ZNS 0.48, what coordination number would typically be predicted? Now we are talking from the perspective of the radius ratio, RC by RA. Let's not talk about what exactly it is. We are talking about that what it could be. it should be octahedral, right? Because it's more than 0.414 and it's less than 0.732. So it should be the octahedral because it's the radius ratio RC by RA is lying in between 0.714 732. It's lying in between them 0.48, and so we can say that the option B is the right answer. Now, what do you say that we know it's not the case over here. Radius ratio is not the is not, we can say that we can 100% rely on this, and so it's in some of the cases it's found to be incorrect. And okay, we'll see in the I think I not made question based on that. Okay, so what do you think, what coordination number it have in reality, ZNS? Option A, right? Abhishek is saying that the option A, it is having that the tetrahedron. It is forming the structure of the diamond type structure it is having, where zinc is sitting at the site of 1 by 4, 1 by 4 and 1 by 4. And while sulfur is forming, we can say sulfur is forming the FCC. So ZNS is a FCC with the motif of zinc and sulfur at 0, 0, 0 and zinc at the 1 by 4, 1 by 4, 1 by 4. Let's move to the next part of our discussion. The true or false type. Okay, let me hide, then we'll do one by one. So the option A, soda lime glass have the high melting point than the fused silica glass. What do you think? Is it right or wrong? Soda lime glass, they are telling, has the highest melting point than fused silica glass. It's a false, right? It's the other way around. And that is the reason why we are adding soda and Na2O, just to reduce its the melting point. That was the only reason. Now, silicate tetrahedral in the quartz form the periodic, corner sharing network. So what do you think? They are talking about the quartz. Is the quartz crystalline or amorphous? Based on that, we can answer it whether it's a true or false. So what do you think? Whether it's a true or false? Silicate tetrahedra in quartz form a periodic, corner sharing network. The answer is true. It's a true. Yeah, that's right, lady. Quartz, we know it's not amorphous, it's crystalline. Since it's a crystalline, so it will be periodic. Now, a corner sharing network, because we know that this oxygen is carrying the charge with them. So if one more tetrahedra one more oxygen come and share that charge, then it will be it's easy for them to form the network and they will spread like that. And with that, we can say that okay, it's the right answer. Now, option C. Third question. In a soda lime glass, Na2O is a network former and the SiO2 is a network modifier. It's a false, ready, and Abhishek also is telling that it's a false. That's right. So it's a false. The thing is that they are other way around. It's network former and network modifier if we change their position now. So Na2O is a network modifier and SiO2 is a network former. With that, we have solved this. Let's move to the next question. It's a mass pair type. I hope it's visible. Let me write 1, 2, 3, 4, 5, 6. Now we'll start with the crystalline solid. What do you think? In crystalline solid, Which one will be the right answer? Option B, abscisic is right. So option B is the right answer, that it's a crystalline solid will have a periodic atomic arrangement. That's a B. B is right. Amorphous solid. It's a C. It lag long range translation order, and that's and the translation order is the one which is very important for us for a structure to be the crystalline. So we can say it's the options. Right answer is C. Silicate tetrahedral. Silicate tetrahedral will match with which of them? Uh, Silicate tetrahedron, we know that it's a basic unit of the silica structure, so it will match with the option D, right? Again, they are talking about that structure only which we talk, like Si is there, oxygen is there. So this is silicate tetrahedron. What about the quartz? Quartz, whether it's amorphous or crystalline, yeah, ready telling that it's the option E is the right answer. So we can say that yeah, 4 is crystalline. Fused silica glass. Fused silica glass will match with the option F. That's right. The only thing remaining is that Na2O, and we know that last question also we saw that it will match with the, it's a network modifier. So it's the option A. So with that we have solved this question. Let's move to the next question. Now, the angle between the carbon-carbon bond in the tetrahedral structure is approximately, so among that, what do you think? Which one is the right answer? Tetrahedral structure they are talking about. Option C is the right answer. They are forming the tetrahedral structure. So 109.5 is the right answer. जस्ट मिनट गैस, भैया हम आपको थोड़ी देर बाद कॉल करते हैं. सॉरी अभी नहीं, 4:30 बजे बचेगा. ओके, सॉरी गैस. So with that we have solved this question. Option C is the right answer. I told you it will be more or less rapid fire type of question. Match the pair. Polyvinyl chloride. In polyvinyl chloride, with what we replace? Okay. See, we have C, H, H, then C, H, H, and then this will keep on going. Abhishek is telling that B. So in polyvinyl chloride, we replace with the chlorine atom. That's the right option. B is the right answer. And polytetrafluoroethylene. Fluoro itself word mean that, yeah, fluorine, yeah, perfect. That's right. Second is C. And polymethyl acrylate. So they are talking about the acrylate. So acrylate group will select the acrylate group. That is option D. Yeah, right. Option D is the right answer. And polyacrylonitrile. So we'll select the nitrile group. That is, it will replace with the Cn. So option E is the right answer, right? Perfect. Now only the remaining is polyester, and we know that it is going to match with this. So here we can say it will be matched with D. Guys, remember this structure. We are going to study a little bit more about this. Like we are going to solve few questions. So it is something like this. In this structure. In upcoming questions, we'll see few things about this particular thing. Let's move ahead. It's a very easy question. We can easily solve this. What is the key characteristic of the thermoplast? What do you think? A, B, C, or D? So they are talking about the thermoplast, not thermosetting. Thermoplast is something which is like is easy to save, easy to melt. Like if we heat up, we can easily save it. Abhishek is stating that the option B is the right answer. They soften on heating and can be molded. That's right. They cannot be reshaped? No. They have the primary bond between the chain? No. We know among between the chains there are only the van der Waals bonds. Okay, so it's incorrect. They have the strong cross linking. Cross linking is not there here. Only the we can say that the branching are there to a certain extent, but the cross linking is not there. So with that, the thermoplast will have they will soften up on heating and they can be molded easily. Let's move to the next question. So we are about to finish very soon. Like now again, in the thermoplast, the polymer chain are held together by. So the two chains between the two chains, what kind of bonding is there? Van der Waals bonding. Yeah, that's right, Reddy. Option C is the right answer. Covalent bond within the chain, carbon carbon. Those bonds are the covalent we can say. Ionic bonds are not there until unless you are adding something. Uh, Hydrogen bonding not there. Now, what does the term tacticity refer to in a polymer structure? What do you think? In tacticity, what is mean? The molecular weight of the polymer does it refer? The arrangement of the substituted atom along the polymer chain, melting point of the polymer, elasticity of the polymer. What does the term tacticity refer to? Yeah, option B is the right answer. It will tell about the substituted arrangement of the substituted. Okay. So with that we can see option B is the right answer. Now let's have a little discussion on this tacticity. So isotactic, what do you think? With what it will match? Option D, chlorine atom are all on the same side, right? That's right. Isotactic means that they are on the same side. Syndotactic. Option B, the chlorine atom alternatively on the opposite side. That's right. So Abhishek told that option B is the right answer. And atactic, we know that which one it will fit? Option C. It will fit the option C. Ziegler-Natta catalyst, we know it can control the tacticity in the polymer. So we will match it with the A. Let's move to the next question. There is another type of classification we learned about the polymer, especially for the copolymer, random, alternate, block and branching. So let's talk about that. So random copolymer. What do you think? In random copolymer, what will happen? A, B, C or D? Yeah, that's right. Both of you are right. Perfect. So we can say it will be randomly arranged, monomer arranged without any fixed pattern. Alternate copolymer. Option B is the right answer. That's great. Block copolymer. So A or D? Option D is the right answer. Large segment of one monomer, then it will follow by the another, then again it will follow by the one monomer, then so on and so forth. Branched, only one is left, so it's very clear also that it will be a branching will be there, a backbone will be there with another branching of. So we can say it will match with the option A. So with that we have solved this question number 23. Now we'll solve the question number 24. Okay, this will be 24. What is the structure of the Morse polymer? It is fully amorphous, fully crystalline, something mix, or we cannot comment upon that. So what do you think? Is the polymer is entirely amorphous or entirely crystalline, or it's something mix among that, or we cannot comment anything on this thing? A mix, right? That's great. So option C is the right answer. So Reddy has told that it's option C. Huh? So it's a mix. So there will be the some kind of a branching will be there, like a chain will form this particular type of structure, and it can lead to the some amorphous thing also. A given chain can take participation in the crystalline form, and it can also participate to the amorphous form. And so we can say that with the mixture of the crystalline and the amorphous region. So with that you have solved this question. And option C is the right answer. Now only one question is left. Since I found that this type of question was there in the assignment, there is one question, something like this in the assignment. So I am also taking, since I cannot solve the same question, I am taking something similar to that. So polytetrafluoroethylene. I told that we'll remember the structure. If the degree of polymerization of this is 400, then find its molecular weight. Okay. So degree of polymerization is given, which is 400, and the structure is given to us, that is not hydrogen fluoride. To form the chain, this bond will break and it will spread. Now we want to find the molecular weight. So degree of polymerization is given. We know that degree of polymerization is equal to the molecular weight divided by molecular weight of one monomer. Great. Degree of polymerization is 400. Molecular weight of polymer we want. Molecular weight of monomer we need to find. The structure is C2F4. So we know that carbon is, let me ready telling that it's a 40,000. Okay, let's just I'll also just complete this. Carbon, I think it's a 12, so 12 multiplied by 2, plus fluorine, I think it's 34.5, if I'm not wrong. So this is what we have to calculate over here. So it's a 24. For 16, 8. For the 12, 13. I hope I'm right. Then molecular weight of the polymer will be the product of these things. I'll use the calcium. So we can say that what I have to do is I have to multiply 400 with a 12 to the 24 plus multiplication of 34.5 times 4. So it is coming, to me it's coming something around, or did I made any mistake over here? So let me check, ready is telling it's a 40,000. Let me cross check the molecular weight of the fluorine. Okay, yeah, I made a mistake over here. Fluorine is something like 19. So molecular weight is 19 over here. So here we can say that instead of 34, I have to write, it's a 40,000. That's correct. So overall, we can remove this. So molecular weight we are getting 40,000. So this is a formula which we used. degree of polymerization, which is molecular weight divided by molecular weight of the monomer. If you know this, you can solve the question. Okay, guys. So that was all from my side. We discussed about the 24 questions. I will just display the questions in front of you again. If you have any doubt, please let me know. Also, if you face any doubt in the last assignment which we solved, as I think week 3 assignment, then you can let me know. We can discuss them also. 22, 23. Okay, I think I made more question, but the question number I made it wrong. So here we discuss about the thermoplastic, that they are linked by the van der Waals force. Here we are discuss about that thermoplastic and thermoset. Thermoplastic, we know that it will soften upon the heating. Here few things we studied about that, the substitution, like the hydrogen will substitute with what, so that this type of we can say that this kind of monomer we will get, and correspondingly polymer. Then here discuss about the angle between the carbon-carbon bonds. Then the amorphous structure we discussed about. Soda lime we discussed. Here we discuss about the ZNS structure. Regarding the coordination number, then we discuss about the CSCL, that why it is not BCC and all those things we have discussed. And then we discuss about the coordination number. RC by RA. And they will correspond to the coordination number of 8. So this is what we have discussed. And then we discuss about the NaCl structure. Again NaCl. Corresponding to critical radius ratio, we discuss which kind of coordination they will form. These are the few basic questions which we solved, that like the depending on the bonding, the coordination numbers. This is a blank page. We discuss about again what is the critical radius ratio corresponding to the tetrahedral. This is the same thing. The bonding, in the nature of the bonding in the metals, we discuss few questions on the buckyballs, and the structure of the buckyball we discuss. Banu has raised the question. Yeah, please go ahead, please unmute yourself and we can discuss the doubt whatever you have. Banu Gopal sir, whatever the question you have, please let me know. You have raised the question, so you have raised your hand, we'll discuss whatever doubt you have. You can unmute yourself if you are, because you are not audible to me. If you, or else you can write your question in the comment box also. Okay, no problem. I feel there is no question. So here we can see that the CNT is there, and we discussed that it is a rolled up sheet. These are the list of the content that has been discussed in the class. And with that, today's dot solving session is over. I will again encourage you guys, please, if you have any doubt, let me know. If not, we can wrap up this particular session. Let's see the answer of the last assignment if it come out. Week 3. I not submitted the quiz. Answer is out. So here it is. Oh, where it went? Here. So we can say that there was a question on the, this is already been done in the class, you just have to write in the terms of A, and then we can say that this is again the thing which we have discussed in the dot solving session. More or less this is also has been covered in the dot solving session. Yeah, and then this is there, interstitial side. We discussed about this particular question, and I told you that it's already been done in the class, like we can say that in the lecture itself Professor Rajesh Prasad has covered this, and all the questions were so easy. And next is a week 4 assignment. Let's see the assignment just. So you will find that this confirmation question is very easy, and then this particular similar type of question we have solved this, and the crystalline solids, very easy. All these questions more or less we have solved. We not solved anything on the this particular type of thing where we can talk about the notation, MN notation. But you can say that if things are same, MN and are same, then they will form the armchair. If they are, one of them is zero, then they will be the that zigzag. And the remaining things are okay. This is little bit of mathematics, but you can very easily do it. And with that, yeah. So with that, we are done with this particular today's our doubt solving session. Since there is no doubt, we'll wrap up this particular class. I hope we guys can meet again next week. And one more thing, guys, there might be some changes in the timing for the next week, so keep so you can always keep checking on the announcement. It might be I might shift it to some other day, maybe on the Tuesday of the next time, but I'm not sure because one conference is going on. So accordingly, the here it will be updated. Okay, please look on to it. Okay, guys, bye bye.